Hi, welcome to Speak Up for Our Planet. We're glad that you found us. All of our videos are of experts talking about what they're doing to save the planet and how you can help too. You might like to watch the videos live and ask the expert questions. In that case, just visit our website and click Join Us. Hope to see you soon. Paul Eastwood is Head of Energy System Planning at Ofgem in Glasgow. But he isn't here in his professional capacity, not really. He is dedicated to reducing our reliance on fossil fuels. And he had gas central heating, like so many of us, but he wasn't happy with that. So he wanted to install a heat pump. And he lives in a Victorian terrace house in Glasgow. And I think lots of people were saying to him, no, you can't put a heat pump in a house like that. But I get the impression that Paul is the sort of person that doesn't take no for an answer. So he didn't accept that. And he has installed a heat pump in his Victorian terrace house in Glasgow. And he's here to tell us about how it happened, what he did. And as I understand it, he's had it for a good year now. So he's actually able to tell us what it's like to live with it. So with that, please may I introduce Paul Eastwood.
Thanks so much, Jane, and good evening, everyone. Nice to meet you all. Excuse me, by the way, my throat is a little bit sore, so I might have to take a sip of hot tea every now and again. But let me just share my screen and we can get underway. I think it might be this one. Does that look okay?
That's perfect. Yep, that's fine.
Okay, yeah. So, Jane, as you said, I live in a Victorian terrace home in Glasgow. This is my home here on the right-hand side. It's very typical for Glasgow. Made of sandstone, 3 stories. We've converted the roof as well. 3-meter high ceilings, a lot of space. It's about 190 square meters internally, but with 3-meter high ceilings on 2 floors, it's a big volume, and it's not very well insulated, but I'll talk through all of that. So just to give you an overview of what I'll run through. So my objective was to get off gas. I've worked on climate and energy policy for quite some time now, and I moved back into my house during COVID and immediately thought I wanted to get off gas. So there's my gas consumption over the last few years, and it ended in June 2023 when we installed the heat pump in the house. And I have no more gas consumption in the house, no more gas meter, no gas consumption at all in my home. So just, I'll talk you through the journey. I'll give you an overview of the journey we went through, myself and my wife, the equipment and materials that we used and installed, performance and costs, give an overview of what it feels like to have a heat pump, what the efficiency is like, the costs, because people are always interested in that, and then just wrap up with a summary of my experience so far. So just to outline the starting point. So again, there's my home. It is insulated, but not very well. The roof, when we first started the journey, had very minimal insulation. Because it's got this room-in roof, it's quite complex. Underfloor, nothing at all, very cold. You need slippers in this house. The floors are not warm. And the external walls made of sandstone. So, you know, they do retain heat well, but it's 125 years old. I'm sure some of you live in houses that old. This is typical for UK. It's pretty leaky and not very warm. Windows, it has double glazing throughout, but you can probably see their sash windows. They've been replaced. They're not the original ones. They're quite modern wooden sash, but they're not very good. There's no real thickness between the glazing panels. So, you know, they're better than single glaze, but not massively better. We have some Velux in the roof. They were fairly old as well. So it's all variable quality and quite mixed. and we had a gas condensing combi boiler. It was only about 7 years old. We replaced it ourselves when the old boiler packed up. So fairly efficient, but we weren't running it very efficiently either. We were typically, heating water, the central heating to 65 degrees C and 50 degrees for hot water, so more than we needed to. And for cooking, we used a gas stove top and had an electric oven, so we were consuming gas for our cooking as well. Okay, so the steps we took to decarbonize, and this is just the back of my house. You can just see from the rear view. It's got like a little extension off the back of it, but it's ultimately just a terraced home with one room, a single story off the back. So in October 22, we started the journey with a home assessment. What I mean by that is we paid for an independent assessor to come to our home and give us a view on the steps we could take to decarbonize our house. So to insulate it better and to install a heat pump to get it ready for a heat pump. In January 23, we then installed extra roof insulation. And then March, May, that spring, we installed triple glazing in some of the windows, some of the ones at the back and the Velux. They were bad windows, so we selected some windows and decided to go for triple glazing. And then in June 23, we installed the heat pump and then had the gas meter removed. So it was about a year it took. I mean, it was 6 to 7 months for the main work, and then finally it took us a little bit of time to get the gas meter removed, and so we completely came off gas. So I'll just talk through a little bit about what that looked like in detail. So the first step was a home assessment. So an independent assessor we paid to come in and give us their view on the heat loss or heat demand in our home. So the graph on the right shows the assessment. The numbers on the y-axis are watts. So watts of energy that are being lost per building element. So the tall bar on the left is ventilation, means our home is pretty leaky. So we're losing a lot of heat through it not being airtight. We're losing most heat through it not being airtight. And then the next one's external walls, not very well insulated, ground floor badly insulated, external windows, bit not so good, roof actually not so bad. They assessed it to be not so bad, but and then it got better from there. So the worst area is ventilation. Now, these figures matter because if you add them all up, it gives you a total figure for your heat demand of the house. And the heat demand is, for my case, it was 14 kilowatts to start with. That's the level of heat input the house was estimated to need to raise the temperature indoors from -4 degrees to 21. So an increase of 25 degrees C. For the calculations, they assume it's -4 outside, and you want to get it to 21 degrees inside. So you might, they assume the worst conditions, and for Glasgow, it's -4. There's a standard they apply. We then undertook some additional measures, and they revised their estimates, and they brought that down to 9 kilowatts, so a 5 kilowatt reduction after some insulation and after the triple glazing was put in. Now, this really matters because heat pumps need to know that demand. You buy a heat pump that can push out a certain amount of heat. They come in different sizes. You can get a 3 kilowatt, 4, 5, 6, 7, 8, 9, 10. Mine is a 13 kilowatt heat pump because the manufacturer could only do an 8 kilowatt version and a 13 kilowatt version. So the installer said, go for a 13 kilowatt because 8 might not be enough. And that's really important. A larger heat pump means more costs. It's like buying a bigger car. It's bigger, there's more materials, it's going to cost you more. So there's higher upfront costs. And so also, if it's bigger, it might not be able to come down to modulate down. So on a day like today in Glasgow, it's about 11 degrees outside. The heat pump only needs to kick out about 2 kilowatts to keep the temperature nice and toasty in here. It's about 20 degrees in here, 19, 20 degrees. It only needs 2 kilowatts. If it's a big heat pump, it might not be able to come down to 2 kilowatts. So it might be running at, say, 6 or 7, but it only needs 2. So it's running very inefficiently. So heat pump sizing is key. Really, really important to get the right heat pump size. If you get an installer and they don't talk to you about heat pump size, and they don't do a heat loss assessment, and they don't explain to you about heat loss and heat pump sizing, just show them the door. Ignore them. They're not worth spending any time with. It really, really matters a lot. Okay, so then I'll just rattle through some few slides showing the kind of measures we installed. So we put some roof insulation in. Our choices were take the entire roof down from the inside and fit insulation between the rafters. That was going to be massively expensive. So we just overboarded with PIR with plasterboard over the top. So basically we lost about 60 mil height and wall depth all around the roof. And that's made a difference. It's made it a lot cozier up here. So that was all we did on insulation before the heat pump was installed. Remember, we've got no external wall insulation, no underfloor insulation, pretty dodgy or mediocre glazing. So this was the only thing we did. We thought, let's just really max out on the roof insulation. The reason we didn't do floor insulation is that we've got very nice wooden floor that's quite modern and new. It's a really, really nice floor. The previous owner was a bespoke furniture maker, and he used super expensive wood. We cannot rip it up, and we can't get underneath it either. We've tried, even with robots, and we can't do it. So we've just had to forget that. So the roof was the part of the house we thought we can insulate it more. Let's max that out. We put new Velux windows in, 2 big Velux windows in the roof, triple glazed, Krypton filled. This was the best thing we could buy. You know, might as well, if you're going to spend the amount of money we did, might as well spend just a couple of percent more and get the very best we could. So we did. These were the rear windows. Just the picture on the left is not, the trim's not fitted yet. That's why it looks a bit funny. But we bought triple glazed windows for the rear of the house. And I must say, this is the best thing we did. If you're ever going to replace windows, get triple glazed. They are absolutely fantastic. It's the first time I've been in a house where it's been below -5 outside, and the glazing is warm to the touch inside. It's not cold, it's warm. It really makes a huge difference to comfort levels in the room. So I'd highly recommend triple glazing. There's some good companies out there, a lot of Nordic companies that make good wood timber frames, engineered timber frames with triple glazed panels in. So this was, again, the best we could get. Okay, so the heat pump. So one thing to remember with the heat pump is that electrics are key. You need to have a good electrical supply. So we're in a terrace, so we've got the consumer unit at the front of the house. The heat pump was going out the back. So the installer needed a big armored cable. You can see it there from the consumer unit under the house to the heat pump. If they couldn't do that, there was no heat pump. So the routing of the cable is key. We didn't want the cable, you can see our floor there, that I didn't want to rip up. They could just about string it underneath the floorboards. And if they couldn't get that in, the only other option was to chase it through the walls. It would have been a real mess. So I was really pleased they could get it under the floor. And the other thing they had to do is create a concrete pad to put the heat pump on. We dug up a bit of garden, we dug up a small tree, and they created a concrete pad to site the pump on. So there's some mini groundworks to do and some fairly big electrical works. And there's the heat pump. It's a Stiebel Eltron, which is a German make. They've been around for years. It's a fairly large unit. It's 13 kilowatts. But this is all fairly standard. It's a monoblock, so it just sits there. It's a sealed unit. It's got the refrigerant all sealed. It doesn't need to be primed or anything. My one regret with it is that it uses a refrigerant called R410A, which has a high global warming potential. Most of the heat pumps now run off propane, which is very low global warming potential. Still a fossil fuel, but far lower than these. These are hydrofluorocarbons. So when you buy a heat pump, if you're thinking about climate change, as most people are, then ask what the refrigerant is. And in fact, there's some really good heat pumps out there now using propane, which has a very low global warming potential. But other than that, it's a fantastic heat pump. It's considered like a premium brand, so we did pay a bit more for it. It has a backup heater in case the compressor fails. It has a backup heater. So we can run it even if the compressor fails. So that's an added bonus for this particular brand. Okay, there's the inside of the house. They call this the plant room. So you can see that it's like a SpaceX rocket booster. That's the hot water tank. You have to have a hot water tank with a heat pump. We had a 300-litre tank fitted because our house is 5 bedrooms, even though there's only 2 of us in it at the moment, while our kids have left home. But they said we size it to the house, not to the occupancy. So we size it, you got a 5-bedroom home, you need a big tank. You'll see it's got a couple of expansion vessels because this is a pressured system. So one for the heating, one for the hot water. So 2 compression valves, 2 compression tanks. You can see, if you can see my mouse moving, you can see there's another consumer unit there. There's pumps and there's the control box too. So you can see both pictures. There's one without the lagging, one with the lagging that was taken a bit later. So a lot of pipe work. It's complex stuff. This was a really, really premium install. We paid a bit more for it. But quite honestly, we couldn't even get any other installer. We tried. We tried to get 3 quotes. We only managed 2, and one of them was rubbish. So in the end, we went with the one installer who we felt confident with. They were definitely not the cheapest. I think now we could probably do a lot better. But this was 18 months ago. The market was really immature back then. It's changed a lot now. Okay, we had 5 radiators upgraded. We've got 13 radiators in our house. So it's a 5-bedroom home. It's quite big. We had 5 radiators upgraded. Literally, the existing radiators popped out, new ones slotted in. So this is on the left is our bathroom. That's the 3-panel radiator now. It was 2-panel, 3 panels. They're really big and heavy and chunky. But it just slotted straight in. You just get more depth. The one in the middle is in our kitchen, and the one on the right-hand side is in our bedroom. A tall one. That was the best they could do in the slot, is actually elevate it higher. And we weren't bothered with any fancy designs or anything. We just wanted a radiator that functioned well and was efficient. So they put these in because the heat pump runs on lower temperature. Our heat pump is designed to run on 45-degree flow temperature maximum. The maximum temperature they would expect when it's -4 outside and you want 21 inside is 45-degree flow temperature. So a minimum 20 degrees lower than we're running the gas boiler. And because it's running at a lower temperature, you need bigger volume. So you need bigger radiators. So we had, I think it was four radiator replacements and 1 additional one. The front room, we couldn't slot a bigger one in. So they just fitted in an additional radiator. So we have 2 radiators in the front room now. The ideal is to have underfloor heating. If you have underfloor heating, then you've got a very big volume, very big surface area for the underfloor heating. So you can run it on a much lower temperature, get much better efficiencies. So what you need is with a heat pump is because it's lower temperature, you need to increase your emitter output. You need to increase the size of your emitters. In my case, radiators. Okay, performance. So what's it like to live with a heat pump? So we've had it in for a year now. It was installed June 23, so we've had a full year, so I can give you full year results. And we're now going into the second winter, just starting. So the house is definitely the most comfortable it's ever been. Because heat pumps are run differently. You run them low and slow. It's like, there's a good analogy with the car, really. So with a car, when you're driving around the streets, it's not efficient to like put your foot to the floor and then slam the brakes on every time you come to a junction. So if you want to save fuel and be efficient, you just gradually pick up speed and gradually slow down. And that's what a heat pump needs. You gradually ramp up and you gradually come down. And the reason you do that, that gradual movement, is because electricity is not cheap. You don't want to consume much of it. And the harder you ramp a heat pump, the harder you push it, the more energy it's going to need, the more electricity it's going to need, and the more it's going to cost you. So to really maximize efficiency, you run it low and slow. So if you push it hard, efficiency drops because you're consuming more energy and for less heat output. Low and slow is the key. So we generally now before we'd have it would be freezing in this house in winter when we'd come home after work, and then we'd turn the gas boiler on, and it might get to 17 degrees by the time we went to bed. We'd be cold, the plates would be cold, everything would be cold in the house. Nothing really ever warmed up. And then overnight it might drop down to 14 degrees again. Now we keep it minimum 17.5. It never falls below that. And normally now in the evening, it's about 19 degrees in here. That's just about the temperature we like it. We don't push it to 21. That's not something we're comfortable with. So we keep it about between 17.5 and 19.5. And it's really even throughout the house. We don't use TRVs. We don't close valves off. We just leave all the radiators open and we just let the house warm up. So it's even temperature, top to bottom, every floor, every room. Really nice warm home. It's the warmest it's ever been. The heating circuit water temperature rarely goes above the design temp of 45. So it was designed to be a 45-degree system. It rarely gets to that. Sometimes when it's dropped down to -5, it gets to 45 degrees. But typically the water temperature in the heating circuit, I mean, right now it's probably about 26, 27 degrees. If you touch it, it won't feel warm at all, but it's giving out heat and it's keeping the temperature inside about 19 degrees when it's about 10 degrees outside. But the water in the radiators is only about, I'd say it's about 28 degrees right now, not warm. So the radiators, the big emitters, are doing their job because you've got a bigger volume of water, lower temperature, but therefore the bigger volume is releasing the same amount of heat as you would if you had smaller volume, higher temperatures. You really want the lowest temperature possible in the heating circuit for heat pumps to run efficiently and save energy. So the maximum, it's interesting because I said about heat pump sizing is really important. And our heat pump is a 13 kilowatt pump. It's big. It's big physically and it's a big output. And it was sized to deliver it was sized to deliver at least 9 kilowatts. That's what the heat demand was for my house. Well, it did drop down to -5 last winter. And so we had the heat pump running at full pelt, and we used 150 kilowatts of energy, electricity in a day. 150 kilowatts. So last winter we were paying 30p a kilowatt. So, you know, that was a lot in one day to be paying for heat, but it was only for one day or a few days. And I'll go through costs later. Overall, we've saved money with the heat pump. So generally, you're noticing consumption a lot more with a heat pump than you would with gas because the price is higher. But what this showed is that if we're needing 150 kilowatts on the coldest day, 150 kilowatts divided by 24 hours gives you 6.25 kilowatts output per instantaneous output. So our heat pump is probably a bit on the big size. But we only run it we keep the house at 19 degrees. So if we wanted to run it to 21, it could cope with that too. And if the temperature drops to -10, which it does sometimes here, that it would cope with that also. So we've got some buffer. And efficiency. So last year, over the heating season, the heat pump delivered 400% efficiency, or a SCOP, a seasonal coefficient of performance of 4. That's really good, especially for Scotland. And an air source heat pump, not a ground source heat pump. So really pleased with that. And for hot water, it was 270%. So different for hot water than for heating, because the hot water gets heated to a higher temperature. We heat it to 42 degrees every day. So it's needing more energy. Okay, and what about costs? Let me just run through that. So these two graphs show on the left-hand side our total household energy consumption and the total household energy costs. I don't have consumption data. I didn't have it for the gas boiler. I don't have it for any lighting or anything. All I have is the meter reading. So for the 3 years prior to the heat pump that we had a gas boiler, I looked at our total annual consumption of energy in the house. The biggest source of consumption of energy is definitely gas. So that's the amount of, on average, over those 3 years, we were consuming this house, 18,000 kilowatts. That's the lot. That's gas That's fridge, freezer, lighting, computers, absolutely everything in the home. The heat pump, for the first 12 months of operation, we used about 6,500 kilowatts. So we got a warmer home for about a third of the energy. And I should say that in this last year, we've got an EV and we've been charging our EV more at home as well than we were in the first 3 years. So it's not quite a like for like, but you can see, I mean, what's immediately apparent is with a heat pump, you use less energy without question, because we're getting 400% efficiency on the heating side, 270% on hot water, you save energy. On the right-hand side is the costs. Now, to explain what I did here is I took the energy price that we're currently paying, the unit cost for gas and electricity that we in our current tariff, and I applied that to the energy consumption over all years, the year for the heat pump and the previous years with the gas boiler, to get a comparable cost between the two periods, the 3-year period on average for the gas boiler running and the last 12 months for the heat pump. So yeah, 2/3 reduction in energy and a 10% reduction in costs with the heat pump. And that's a warmer home as well. That's a much warmer home, much more comfortable home. And straight away, I'm pretty confident we've saved about 10%, probably a bit more as well, because now we're charging our EV home at more, and I can't separate out the different forms of consumption. And then in the spring, I switched tariffs. So now I'm with a tariff that has nighttime off-peak electricity of 8.5p per kilowatt hour. So we charge the EV at night, we heat the hot water tank at night, we do a washing overnight, the washing machine. We're saving, I reckon, 15%, a further 15% on our bills. You can't get those tariffs if you're running a gas boiler. If you're running a gas boiler, you can't get a nighttime tariff. You can only get it on electricity. So a heat pump, switching to a heat pump has allowed me to go to a nighttime tariff and save another 15%. So I reckon we're probably saving 25% on our energy bill with the heat pump. Now we're talking about a £2,000 a year with gas on average, total household energy cost. So that's a pretty big saving. That's potentially up to about, yeah, that's £500 we could be saving every year. Okay, this is the upfront costs. So just laying it out there completely for you. £400 for the home assessment, 5,200 for the installation, but we got a £3,000 grant for that. Just over 5,000 for the triple glazing. Well, 5,000 and then 6,000, so 11,500 all in all. And the heat pump was 17,000. That was at the upper end of things. I don't think we'd be paying anywhere near that now. I think we'd be paying a good few thousand less. But we got a £7,500 grant for that. In Scotland, it's always been £7,500. So before it was increased in England and Wales, it was always £7,500 in Scotland. So in total, we paid 34,000 for these upgrades, and we got a £10,500 rebate on it. So 23,600 pounds to us. So not cheap, but we were really, really happy to pay that. So in summary, my experience has shown that heat pumps can heat old homes like ours, 125-year-old, modestly insulated, and cost no more than gas. And in fact, I think save money, potentially saving up to 10% straight off, and switching tariffs saving up to another 15%. And they're not noisy as well. People worry about the noise, but I can send you video links. I've posted up on LinkedIn. It's really not noisy at all. Key to good performance is good kit and a good install. We paid for good quality equipment, so we paid more for that. We paid for a good install as well with a local installer who does charge a premium, but he's a really good installer, has fantastic technicians, has apprentices that he trains up as well. We knew we were paying a premium for that. We were happy to, because he was really top quality. But you don't want a shoddy install. You can't get away with it. With a heat pump, you won't get the efficiency, and then you'll be annoyed. Especially if you know other people are getting good efficiencies and you're not, because it's directly comparable. It's a bit of noise coming through, is that? Oh, that's better. It's gone. Okay, insulation helps to reduce the demand, so it helps a heat pump, but it also would help a gas boiler. It doesn't matter what your heating is, insulation helps under any type of heating. So if people tell you you need to get insulation before you get a heat pump, that's just not true. It will help, it will improve the efficiency of a heat pump because you can run on a lower temperature. But the same would be true of a gas boiler as well. It's irrespective of the heating, insulation is a good thing to do, but it's not a reason to stop getting a heat pump. You don't need to wait to insulate your home to get a heat pump. A heat pump, as heat pump installers and experts on this tell me and remind me, heat pumps can heat a tent. If you want them to, they can heat a tent. And there's experience of that. Marquees sometimes in the winter will put a heat pump in just to keep people warm inside, and it works. Keeping the install simple as we did, I won't go into buffer tanks. We've got no buffer tank. We don't control the radiators. We just leave the whole system open, and experience tends to be showing that that helps with efficiency. Keep it nice and simple. And we had an independent home assessment. Local Home Glasgow is the name of it's a cooperative that did it for us. And it was really invaluable because this isn't like just getting a new gas boiler. This is a completely different type of heating system, very different. I think about the days when people, before central heating was installed and when people get central heating fitted for the first time, it's that kind of transformation. It's big. So, and of course, the installers are just like all trades. There can be some good ones and bad ones. And who do you trust? An independent assessor can give you heat demand calculations and help guide you through the process. And we found that invaluable. So we paid £400 for that, but it helped improve my confidence, built my knowledge, and I could go back to them afterwards and say, hey, what do you think about this? We've had this quote from an installer, and the assessor said, well, I'm not so sure about that. They were happy to give a bit of free extra advice. So that was really £400 well spent if you've got a local assessor, if there's somebody you can tap into. So I'll stop there. I think that was probably longer than Jane I meant to, but I'll stop there and we can move to questions. Shall I take the slides down now?
Yes, do that. Thank you very much indeed. It's clear that you have a wealth of knowledge and information there. We definitely have some questions already. So let me just open the chat. So from the top, first of all, there are some questions here that people asked and then you answered them before before you finished your talk. So how did you find your assessor? I would be concerned they would sell me things, and how much did it cost? So I think you've answered that question. How you find it is going to be a question of your local area, isn't it, really? And finding
I don't know. There are some independent assessors out there, but there's one in Glasgow, we know. I know there's one in Manchester. I suspect there are some in London, but I don't think they're common. So it's just about looking around and seeing if there are any in the area.
And a similar question, how did you choose an installer? I think you said, didn't you, that you tried to get 3 quotes. Was that with the installer or was that for the actual pump?
Yeah, we tried about 6, I think, and it was just hopeless. The installer base was terrible at the time. I don't think it's much better now, but it's improving. But I think this is an area where you definitely want at least 3 quotes, at least 3, because you'll probably find that the installers will come back and actually offer you quite different systems. So that raises questions. Why are they coming back and offering different systems? But the key to it is they must conduct a heat loss assessment. That means they need to go and measure every room in your home, measure the dimensions. They need to make an assessment of what the insulation levels like in every single room and come back with a full heat loss calculation, just like the graph I showed you, and an assessment of whether every single radiator in the house is capable of meeting the heat loss, the heat demand in each room where it's situated. So I've got all the graphs of that as well. I didn't show them, but I've got all those graphs. If they don't do that, show them the door.
Mm.
Just not worth dealing with because they're not serious. They're just trying to quickly fob you off with the system. The network that is springing up that could be probably recommended is Heat Geek. So there's like a Heat Geek certification. So that's a good place to start with, I think. There are certain groups which are offering certain standards for installs, so they're worth looking into.
Oh, that's interesting, because that was going to be my next question. How do you, is there some standard by which you can judge whether these guys know what they're doing or not? So it sounds as if this kind of stuff is happening as we speak. It's getting more and more possible to find installers, but slowly. Is that a reasonable summary?
Yeah, I mean, you can look on the Energy Saving Trust has a site of installers, and what's useful there is that they have reviews attached to them. So, I mean, go with ones that have lots of good reviews. I have known people who have gone with an installer who's then gone bust and did a bad install. So, it's like with everything. This is the most expensive thing we've ever bought, outside of buying a house. So it's not a decision to be taken quickly. I think you really need to have confidence in your installer, and the way to do that is to word of mouth, good reviews online, build up some confidence with them. Do they answer your questions? This is many thousands of pounds.
Yeah. Thank you. Okay, so Mary Nettle's got an interesting question. What alternative fuels did you explore? Did you think about using hydrogen in your gas boiler?
Absolutely not. Well, for one, where would I get the hydrogen from? There is no hydrogen. There is no hydrogen supply at the moment, and there probably never will be. That's my own personal opinion, of course, nothing to do with my professional background. I don't think there ever will be. There might be in a few limited locations around the country, but no, we're going, the direction of travel is electrification, and there are so many benefits. And just as, I mean, indoor air quality is one of them. I mean, we don't need carbon monoxide detectors. We have no methane pouring into our house anymore. With a hydrogen system, it's shown you need to actually, the hydrogen homes that have been tested, you need to punch holes in the wall to allow adequate ventilation, because hydrogen is highly toxic. Why would you want that in your home? It's like gas boilers. We've gotten used to having toxicity in our home from things which are keeping us warm and feeding us, but we don't need that with electricity. It's wonderful and clean. And then you can also play with it. You can go on different tariffs. So I mean, it was 2 minutes to change tariff on Octopus, and I'm saving 15% of my bills. I mean, that's enormous.
Yeah, we have the same deal with Octopus, only because we have an electric car. But even with that, it's amazing how much we can save. Yeah. So John Smithson asked, what is the noise value when the heat pump is working? You said it was quite quiet.
Yeah, I can. I mean, so I've taken videos of when it's running, when it's covered in snow, it's in the middle of winter. There is a humming sound. What's interesting about the video I took is that you've got to listen, because the birds are tweeting and they're drowning out the sound of the heat pump.
Oh, brilliant.
Yeah, so I'm happy to, Jane, I can share that link with you. It's all on LinkedIn. But I thought that was interesting. And we've got, our neighbours have got combi boilers. They've all got flues. They're making noise. So noise is definitely an issue. They're not quiet, just like your fridge and your freezer is not quiet. It's the same thing. You hear a compressor running, you hear a fan running. But is it a problem? We've normalized cars. So, I think this is just something to accept is the way we're going. I mean, also, I've lived in the tropics where air conditioning is normal. So you just get used to fans humming. It's just part of life. But it's not noisy.
I've just got a little message which says John's iPad has raised hand. So if you called John's iPad, do you want to unmute yourself and say something?
Oh, yeah. Hi. Yeah. Can you hear me okay now? Sorry, I've just unmuted.
Yes.
Yep.
Yeah. I'd just like to go back on the costs. So you showed a graph of your energy savings, but it was difficult to judge because the insulation had changed compared to gas. But what's your estimate of your payback period for the heat pump compared to the energy savings? What's your estimate for that?
You mean paying back for the heat pump?
Well, paying back for your investment. So you invested £23,000 and you had a grant of £7,500.
Yeah.
So against that initial investment, how long will it take you to pay it back based on the energy savings, excluding the insulation? Because the gas wasn't with insulation.
Well, you know, it's interesting because I do get asked that question a bit, but it's a difficult one to answer, and I'm going to flip. And the reason why is because I think it's worth thinking about this in a different way. So if I didn't have any heating at all in the house and I wanted to install heating, I wanted to have heat in my house, I wouldn't be thinking about payback. I'd just be thinking I need some heating in my home, whether it's a gas boiler, or whether it's a heat pump. But what's interesting is that we need the services that we get from heat pumps. It's not like a solar PV and a battery system or just solar panels, where what we're doing is we're buying that equipment and we want to see the payback for it because we actually don't need the service. We're buying that to make a saving, cut emissions, but to make a saving. But with a heat pump, we need the heat. We don't have that. We need a gas boiler. So if we have a gas boiler, would we think about what's our payback period for the gas boiler? We probably wouldn't. But I'm not convinced it's the right way of looking at it. What's the payback? I think we need heat. We need the services from a heat pump. It's just whether we get that service, that warmth, the hot water, and the space heating from a heat pump or a gas boiler. But in terms of like the savings we get from running the heat pump, well, I think with the tariff we get and the initial saving, so the initial saving of 10%, additional 15%, let's say it's 25%, and we're paying £2,000 a year, say, for our energy bill, that's £500 a year, 10 years, £10,000.
Yeah, it doesn't really.
20 years would knock it all off altogether, and the heat pump's probably got at least 15 years life in it.
Yeah, but do you not think that doesn't add up financially?
No, because I need heat. What am I going to do if I don't? I need to keep warm.
Compared to having a gas boiler. I mean, taking aside the global warming impact, just on financials, it doesn't make financial sense, does it?
But it's like saying, what's the payback of a car?
Well, it's not a similar. Cars don't make sense anyway from a payback point of view. We're talking heating your house.
John, I think I'm going to have to stop this conversation because it's a matter of principle here, and this could go on for a very long time, and we don't have a very long time.
Principle.
If you two would like to have this conversation offline, then I'm sure you can.
Yeah,
but it's a question of whether payback is what you're looking for.
I understand you don't want to talk about it. It's a difficult issue, and I'm all for saving the planet, but it has to be realistic, and most people can't afford it. So we need to look at what the options are. Yeah,
that's fair comment.
Okay.
And I want to bring Robert Hall in here because he has recently installed a heat pump himself, and I wanted to ask him how he compares his experience with Paul's, or whether he has any additional comments to make. Can you come in, Robert?
Yes, certainly. Thanks, Jane. Yeah, I mean, we just spent the last 6 weeks installing a heat pump, and so it's a very fresh experience. Which, just to give you some background, I live in Jordan's in a 4-bedroomed house, similar sort of size to Paul's, but it is detached. And like him, our aim was to reduce the carbon footprint rather than try and save any money on it. Company selection, I totally agree, is really critical. In order to do that, what we did was look at the MMCS database. It's a website which has a list of local suppliers. and we invited 3 people to come round. One was a company based at Henley, which had been recommended by a neighbour, and they actually listened to what we wanted, and so we decided to run with them. The other 2 were also local, but they knew exactly what we wanted and told us so, and did reply to questions. So we went with the first company, and the name of it is Oxon Energy, based near Henley. We ended up going not for the sort of refrigerant that Paul mentioned, but for a propane refrigerant, the R290. And the main reason for that is it does create a much higher temperature. The manufacturers say it gets up to 70 degrees output temperature. We've had it up to 60. And the big advantage of this is that you don't have to replace your radiators. However, we did have a choice of either going for one large machine or 2 smaller ones. The disadvantage of the 2 smaller ones is you had to get planning permission from the council, and that is a pretty complicated process. So we went for the one big one. The disadvantage to that is we had to get 3-phase electricity installed, and that's another story altogether, which requires quite a little coordination. So that on one day you have SSE coming along to install the electricity, you have your energy supplier coming along to install a meter, and your electrician to join them all up. So that's quite a challenge. The other major challenge we found was that we had an old, what's called a one-pipe system joining up our radiators, and heat pumps don't work on that. So we've had to have a 2-pipe system, which has proved very disruptive in putting a second pipe around our plumbing system. That's all now done and finished. So it has been very disruptive. The heat pump is now working. There's been a few teething problems, and hopefully next week we'll be able to commission it and it's all running okay. Summarising costs proved much more expensive than Paul's. The cost of the heat pump after the grant has been about £20,000. That's included installation as well. The cost of the heat pump itself is about 15. The electricity supply has run out at £7,500, and the plumbing change is £5,500. I think my 2 recommendations from my experience is, first of all, be prepared for a complicated project. It has proved much more complicated than we expected at the start of the year. And I'd underline the importance of getting a good supplier who is going to be willing to listen to you, to answer your questions, and to work with you through the inevitable complications and problems you're going to face. Thank you.
Thank you. Thank you very much. Very succinct and sort of adding to, but also some differences from Paul's experience. Thank you very much indeed. We do have quite a few more questions in the chat and not very many more minutes. So let me just see what I can do here. I'm scrolling right back. There's an interesting question I saw earlier. Oh yes, what do you do with the heating when you're away? Do you leave it just on doing low and slow all the time, even if you're not in the house?
We have a setback, so we would put it to say 17, 16 degrees, but we can just let it run. We can let it fall down to much lower. It just then takes longer to get back up to temperature because it's harder to ramp.
Sure.
It doesn't like to ramp hard, so it just takes a while to get up to temperature. Once it's up there, it keeps it up there very nicely.
Okay. So if you're away for a while, it's worth letting it go right down, but you know, over the weekend you wouldn't bother.
Yes.
In
That's
summary.
right.
With a flow temperature of 45 degrees, this is Frank, how do you avoid the possibility of Legionnaire's disease in the hot water tank?
Run a Legionella cycle. So it has a cycle that we can do it whenever we like and just raise the water temperature to 60 degrees to kill it all off. So we do that once a week.
Okay.
No problem.
Was a clear, succinct answer. This is from me. I don't understand the 400% efficiency thing. If that's a long answer, don't answer it.
It's not, it's easy. So for 1 kilowatt of electricity, you get 4 kilowatts of heat. A gas boiler can only deliver less heat output than energy input because it's thermally inefficient. Thermodynamics, you cannot heat, you can output more heat than you input in energy. And because it's inefficient, there are losses. So with a gas boiler, you could be getting 50% efficiency. If you really, really, really tuned it well, and it was a modern gas boiler, you might get 85%, possibly 90% at a push. It was really optimized, but typically 80% is good, 85%. We're getting 400%. So it just means your electricity input generates 4 times the output of heat.
Okay, thank you very much. Philip Sheehan has a warm air system, so no opportunity for a wet system. How can I get a heat pump for my situation? Does that make
So
sense?
you can, yeah, so you can get, I've lived in a home with air-to-air heat pumps, so it's like air conditioning units, but they pump out heat as well as cold air for air conditioning. So you can get those systems. They just have units that pump out warm air or cold air if you want for air conditioning. So yeah. There's a question about from Frank. Surely, Paul, with all that additional installation, your gas consumption low and costs would also now be a lot lower. I don't think it's made a massive difference. Quite honestly, I think it's made a bit of a difference. But if we're looking at payback, that's where insulation does get interesting, because will you ever get the return on that investment? I've got this very question right now. I think that is a valid time to ask that question. I'm looking at getting new windows, these ones right here replaced. That and another one's going to cost me £5,000 if I want those replaced. I'm never going to save enough energy by replacing these 2 windows to pay £5,000 off. I could live it for 30 years and I won't have made that much energy saving. So that's why you have to think about insulation levels, and is it really worth it to save the money on your running costs? I think there is a very valid question to ask there about return on insulation investment. I think it's a different question for installing heating, because you need heating. You can't not have heat.
Especially in Glasgow.
Especially in Glasgow.
Okay, I'm running down the questions. I see you've answered some of them in writing, Paul. So
yeah.
that's...
I couldn't sell my gas boiler. I did think about it, but then the installers unfortunately damaged it when they removed it.
Oh no!
So that was out of the question, yeah. Yeah.
So I don't know if other people are looking at the chat, but there was an interesting one about the size of the container for the kit. You say it's about the size of a double wardrobe.
The house already had a hot water tank when we first moved in 12 years ago. And so it was already had a room for a hot water tank and a boiler. So that was just repurposed with another hot water tank in. So, but you do need the space. You need space for a hot water tank. There are alternatives to hot water tanks. So you can get things they're called phase change heaters that use a chemical constituent to store energy. It's like a heat battery, and they're a lot smaller and more compact. So it does the same thing, but just in a more compact size. So that if you don't have the space for a hot water tank, there are alternatives for storing heat for hot water. But you can't use a heat pump, can't run like a combi boiler. It can't heat your hot water instantaneously.
No, right. So there's an amusing little idea that's come up here. It's difficult to know whether things like solar panels and heat pumps increase the value of your home because people who have them don't sell their homes.
That might be true. I don't know. I mean, I think our house is fully electric now. We don't have a meter. It's all been taken away. The meter's been removed. Some people might not like that. I think we're in a point at the moment where that might be off-putting for some buyers, but some people might think that's brilliant, that we've done the hard work for them. We've electrified the house and we've gotten off gas. We've got a very modern home now. EVs, induction cooking, heat pumps, 100% electricity, and some people might like that, but others might not.
Sure. But I think, we here in this forum are all here because we're interested in the whole business of trying not to damage the planet more than we have to. And I think, you know, you've made the point very well that it wasn't necessarily to save money that you did all this. It was because you feel better about yourself because you're not burning all this gas.
Mm.
And I, you know, I admire very much that thought. You're prepared to spend the money because it suits your ethics. We're pretty much at the end of our time. If people want to contact you, Paul, is it okay for me to put your email address out with our next newsletter so that if somebody feels that they have a question they didn't manage to ask, they can ask it of you?
Very happy to. And I can also send you, Jane, a whole bunch of LinkedIn articles as well. LinkedIn articles, videos and posts and things about my experience. So that's a good set of information to share as well.
Yeah.
And similarly,
Okay.
if you want to add my email address, if someone wants to come and look at a heat pump locally, they're welcome to do so.
Okay.
Brilliant. Well done, Robert, for that.
Robert, put it in the chat, and I'll make sure people know it. Rob Cooper says you're able to send out these slides, please. The recording of the talk will be available, but maybe Paul's prepared to share the slides as well.
Happy to. I'll create a PDF and I can send a link to it. No problem.
Oh, perfect, because the PDF's much
Yeah.
smaller than the slide set. Yeah. Laurie, yes, this video will be available for viewing. You just need to either make sure I have your email address or sign up for our newsletter, or however you want to do it. I'll put our email address into the chat. So that is sue.mail. sue.mail at gmail.com. So if anybody wants to information from us, newsletter, recordings, etc., please drop us a line on that. Wow, that was an awful lot of information in an hour. Thank you so much, Paul.
You're most welcome.
Terrific. You're obviously a massive enthusiast. Your home sounds absolutely wonderful. But so and I love the idea that you've managed to do this in the kind of building which I know a lot of people say, no, you can't do that. Absolutely terrific. So thank you very much indeed. Everybody's muted and a camera switched off and things, which means that it's quite hard for us to give you a big clap, but let's do it anyway. Anybody who's got their camera on, please let's have a big round of applause. Thank you so much. Absolutely brilliant.
Thanks for the opportunity, Jane.
We'll circulate your details so that people who feel they've got extra questions can write to you.
No
Thank
problem.
you very much indeed.
Thanks for meeting you all. I'll follow up by email. Bye, everyone.